I'll just be hanging out here for a little bit, eating some food. So if anybody has any questions or whatever, just go ahead and ask, and I will answer. Yeah, you show it's all under version control. We've got a Perforce server running. If you took a look at the blog post that I wrote for the dev blog, basically we've got a server on Amazon. It's over in Virginia, and it's running Perforce for us. And so all of our files are backed up over there, and then we take snapshots of that all the time. So if Virginia gets hit by a lightning strike, we still got all of our data. And you'll see me like pop open some files, like when I right click and do those, and I'm like dragging those off screen. I'm just dragging them over into my Perforce window to check them out. So that's what we're using for version control. Yeah, it's free for it's free for up to 5 people. And, well, we only have 2 people, so, hey, free version control. Yeah, we were using Get for quite a while. I was using Get for all the code before I was working with Adam. But basically, Unreal 4, Unity worked fine with Get, but Unreal 4 does not. There's just too many large assets. Everything's binary. There's no text-based stuff for like saving new assets. So Get just wasn't an option. We tried Get large file storage and some of that, but it's just the tool chains aren't there. It doesn't really work as you'd expect. And debugging stuff with Adam, like Adam's never used version control before this project. So telling him like, oh, here's some like ridiculous command lines to run with get, like just doesn't work. Especially since I can't go over to this machine and actually do anything right there and help him out. So Perforce was just kind of the only option at that point. Yeah, Unreal's kind of a bit of a beast. Like it's the only real way to deal with it is to get the source code for it and compile it yourself, and then you make everything inside of it. And there's just it's kind of the difference. I was trying to explain it to my parents, who are not technical people. They're both very not technical. And I was explaining, I was like, okay, so Unity is kind of like a factory that's set up to make cars. So if you want to make cars, you got to go in there and configure the machines and get them. Okay, this thing's putting on the doors. The doors are going to look like this. These cars are going to be red. These are going to be blue. But all the pieces and parts are there. The factory floor is set. The factory is kind of ready to go. You're not just like buying a plot of land. The factory is there, and you're going to be making what the factory makes. Unreal 4 is kind of a little bit different. It's more like, they give you all the materials to build the factory, and then you build the factory, and then you can make the factory make the game and all the stuff in the game. So instead of showing up to like a factory that's kind of more ready to go, you're showing up and there's like a couple dudes sitting by with shovels, and the truck's coming in and it's got the rolled steel, everything else, and it's like, all right, so cool. Where are we laying the foundation for this factory? And you're like, oh crap. Or at least that's my experience with it. Yeah, I think it works pretty well because with Unity you can build cars, but with Unreal you can build airplanes and tanks and all sorts of other crap. You could even build factories that build miniature factories if you wanted. It just allows you to do that, and you can't really crack open Unity and do that. Yeah, like any independent developer is going to go get the source for Unity. And even when you do get the source for Unity, it's like we're working at Amazon and stuff like that. Like it's just a gigantic hassle. You know, it's Unreal 4 is its code base is moving forward. It's a lot easier to actually go change shit. And Unity, just don't even try. It's also one of the things I really like about Unreal 4 is, you know, we don't have to pay to grab the source code. And if you're not going to edit the source code, at least the source code is there, so you can actually like go walk into it and see like what it's actually doing. So if you really think like, okay, this isn't my fault, this is something broken in the engine, you can go check and, you know, kind of confirm your hypothesis maybe a little bit. And the other thing is it's nice if you're like, I need to save a file or I need to do something else. It's nice to have Unreal 4 there where you can go crack open the code and be like, well, how does the editor do that? You know, how does there's examples for stuff, so you can nicely like copy paste them out of there, and also kind of just read the code and see how it's supposed to be used, and that really helps. Yeah. Yeah, the one big thing with Unreal that just is not there is the UI. Like, sorry, but Slate sucks. Like, yeah. So we've got WebKit. We got embedded Chromium for our UI. We'll be showcasing that at some later date. But I can boot up web pages inside of this thing and do stuff like that. So that's pretty cool. We'll have, you know, we can go watch our YouTube videos from our game if we really need to. Might even have hidden UI where you could go watch all the Brackenwood series in the game. Who knows? Yeah, I was trying to get it so we could get like Toon Boom Harmony to make our screens for us for our UI. Where basically we'd pop open Toon Boom Harmony and we'd be able to just draw out our screen and then all the widgets, and you could just like export all the textures and throw it in Unreal. And that proved really tricky because Toon Boom it doesn't have like a nice data API like Flash does, and some other more programmer friendly packages like your 3ds Max or Maya. All those are very heavily steeped in game development history, so there's tons of stuff that you can just grab. Like, okay, I need this coordinate position, I need these meta tags. Toon Boom just doesn't have that, so we kind of had to bail on that first plan, and kind of fall back to doing WebKit, which has some drawbacks. Basically, like one of the big ones is the WebKit window is basically a window that goes over the whole screen, and as a result, you can't really have like interactable stuff behind it very easily. So it's not, like if you're making an RTS game where you're clicking on units, we'd have to go do a lot of little things to make it actually work. But we don't have one of those. We have basically a game that you'll be, using an Xbox controller for, or your keyboard and just some basic moves. So that's not actually an issue. So yeah, we have that at least. I'm almost done eating here, and then we'll get back to doing this physics. So I'll just go put all this stuff up, and I will be right back. No, thanks for the questions. It's always good to kind of talk about what we're doing. All right, well, we're going to get back and actually doing some work here. How about that? The stream delay, it's just awful. Is there anything I can do about that, or is that I haven't set any delay on any of my stuff? So is it just Twitch? Yeah. It's always awful for non-partners. Well, we're gonna work on that, right? I've been streaming pretty much every day, so I'm working on being awesome. Yeah, I can assume that they get priority for everything. Hey, they're partners, right? That's kind of what happens. So our problem right now is floor 62, and this little bastard is. That's the one. We almost made it all the way up there. We almost made it to spaces. This fat sack. Almost there. But close is not good enough. So let us continue. So the basic thing I think that we're going to need to do there to get us up to the top is we're going to have to keep track of some of our previous frame data. So why don't we go ahead and make a data structure for this. Let's go make a struct, which is going to help us contain all of the basic information about where we have been and what we have been doing. Excuse me, got the hiccups almost. So this is going to be Dashkin movement data. And on this we're going to have our F vector. We're going to have position. We have velocity. And the other thing we're going to take a look at is fixing that frickin' clock. So fix the frame count, because something was going wrong with our frame count on our frame counter and our clock utils, which is not good. So we need our velocity. We're probably also going to want like our movement state and all that fun stuff. Just going to call it mState. Because basically we're going to be able to look up like, okay, well, what were we doing last frame? We were on the ground, this was our position, and we were a flying type or something like that. So let's see, we got M, movement type. We're going to want our, so we have our state, so we're going to have F vector M surface normal. And we'll have our movement data down here. We're going to have previous frame, and we're going to have current frame. And then we'll have some getters for that whole thing. It's going to be get current frame data and get previous frame data. Let's go hide these guys away in the bottom of the file. And we're not going to make them const because screw it. Let's let people modify this. Mainly because we don't care, because we don't have a large project. Not many people are working on this thing, so there's not much of a sense in putting up huge barriers between development layers. So, we're also going to need a few methods on here. So why don't we have a reset method on the movement data, and we'll just like initialize all the stuff to zeros and all that fun stuff. Let's see, Adam's got some questions here. SSH. So to reset this thing, we're gonna set like our position to the F vector, 0 vector, same with our velocity. Our state, we're gonna set ourselves to none. It's our movement type. None. And our surface normal to the 0 vector. Alright, so we can call reset on things. That'll be fine. So what we're going to want to do is basically get the last surface normal. We're going to save it on our current frame data. Let's do our equals here. So the previous frame is going to equal the current frame at the beginning. This is going to be after this, so we're going to do our previous up there. Not a problem. We're going to check our movement, so we are going to want to have our surface normal here. So if we're on the ground, we're going to check our surface normal. So if our m current frame m surface normal, if this equals the f vector 0 vector, then we are going to set our surface normal. It's gonna be g down, and we're gonna invert g down. So our surface normal is gonna be basically g up. And so we're actually down in this case is going to be the negative of our surface normal. So is that what we should do? For detecting if stuff is still there? I don't think so. For basic checks to see if the ground is gone, we're not getting the surface normal from there, so that should be fine. The issue comes if... Okay, so you're going to figure out our direction of motion, and our direction of motion is going to be based on the surface normal that we are currently standing on. So what we're going to need to do is actually use the surface normal. Well, let's think about it real quick. So we're on a surface, and that's where we were last frame, and if we cast here to see if we're, in this direction to see if we're actually still on something, seems okay. Otherwise, we're gonna like set ourselves in the air. So what if during this frame, this turned into this, and we were on it, and like we cast our normal, it's like, oh, you're not on the ground. It's gonna set you as being in the air, and then we're gonna resimulate, and we're gonna basically get stuck onto the ground immediately anyway. No, we've got a bigger problem than this, don't we? Like, let's say that we're falling and we fell onto that floor 62 and our surface normal is all sorts of screwed up. So we're going to have to figure out a way to get the correct normal for that floor 62. And we're going to need to be able to figure it out without using previous frame information. And how do we even detect that that surface normal is improper? Like, how do we know that that information is toast? Let's take a look. See if there's any rules that we can come up with for this. Trying to look up online to see if any other people are having problems. Well, let's see if we can find anything that would give us a heuristic or some other clue as to what we should watch for. Because if we have this frame and this frame's information, we should be able to, I mean, we can do another trace, you know, to like get the true normal or something like that. Like we could see what we hit and see if there's something about that that's wrong. But if we landed on this thing, we would not be able to land on it. So our starting position is such that one velocity is to the right. Surface normal is completely wrong. The movement direction is this. So we cast a ray down, and the normal to the surface was a certain value. Well, let's take a look here. Maybe there's something else wrong. Maybe there's something else that we got wrong, right? Maybe it's not something wrong with the normal here, but maybe we got the wrong goddamn surface or something like that. So if we're going through here and the surface normal is getting set to Z is very high. The hit was against floor 62, which is that floor. The impact point is such. Is there anything wrong with the impact point? I mean, it's at 85,000, which shouldn't be a problem. The trace start and ends are okay. I mean, there might be another issue here where the trace is just, the end of it is too long, and we're getting some mathematical precision issues or something. Like, we did see problems with that before. So it's definitely just given us the wrong thing. And I was thinking, like, well, maybe we're hitting multiple objects with our trace, and maybe we're picking the wrong object or something like that. But it does not look like that's the case. So let's try changing our distance. So what are we using for the basic distance when we're saying a direction? Using far enough. So if we have a direct end is going to be get safe normal times distance. Is that what we're using? We are using far enough. Well, why don't we try setting far enough to something else, like maybe it's just too big. Let's try setting it to 10 million. We'll set it to 10 million. 10 million's far enough, right? Because maybe we're getting some sort of mathematical floating point error because we're dealing with too big of numbers. And why don't we just move FatSack starting location? Move it over there. Movement direction is negative z. So we'd be moving down. Yeah, it's giving us a normal. As if this is just flipped. Why would it flip and why would it flip now? He's also dipping into the ground, you can see that. Like, wham, into the ground. Alright, so our normal is correct. And then it's incorrect. So what happened here? Our suggested position after the sweep is this. Our overlap did not hit, setting to the new suggested position. Starting position is such. Our wanted velocity is this. Our surface normal is correct. The movement direction is this, which is high in z, low in y. Movement distance of 15. Our position after the sweep is such. The impact point for the downward sweep is that location. The surface normal on impact for downward is wrong. So after we moved, so we actually had a frame here where the surface normal went from negative to positive. Like the surface normal just flipped. Like 34,202 to that. Well, see, this is 61. That's 61 still. So this is 462. So what we're going to do is we're just going to see if there's... Like, we can still move up. Except when we hit the middle of this next object too. And we can move down. Except you can see that there's a bit of an issue when we go over that midpoint when we move down. It's the same thing. We're getting just the wrong frickin' math. Like, what the hell is going on here? Alright, well, I guess what we have to do is debug the core engine code then. Like if we're getting the wrong impact normals here.